There must be over 20 capacitors on this circuit board. The large purple ones, you can see the values printed on the side, and small green ones. A capacitor is a device for storing energy in the form of an electric charge. Here we have a series circuit consisting of a capacitor, a multimeter, and a power supply of 4 cells. The circuit diagram will look like this, except that in the components you can see, the circuit is not complete. We've left one of the wires loose. Just to quickly show you what happens when we connect the capacitor and make a complete circuit. When we connect the circuit, a current flows for a very short time. The needle kicks up. Once it's done that once, it won't do so again because the capacitor is fully charged. If we then disconnect the capacitor from the power supply and simply connect it across the meter, the needle tries to go backwards as the capacitor discharges. When a capacitor is being charged, the power supply pulls electrons from one plate, leaving that as a positive charge, and pushes them onto the other plate, which gives that a negative charge. The charge on the capacitor builds up until you reach the point where the power supply has insufficient energy to push electrons onto the plates against the repulsion of those already there. The purpose of a capacitor is to store energy in the form of an electric charge. It has a value of 1 farad if it stores a charge of 1 coulomb with a potential difference of 1 volt. This connects with the equation that capacitance equals the charge stored divided by the potential difference across it. This stored charge will have energy. We can calculate electrical energy from charge times potential difference. As a capacitor discharges, the potential difference across it will fall at the same time. This is a straight line relationship, as you can see on the graph. The energy released by the charge leaving the capacitor will be equal to the area under the graph. That area is equal to 1/2 times the maximum charge times the maximum voltage. So the energy stored is 1/2 QV. To help you understand how a capacitor works, I'll just quickly show you how one is made. All it consists of are a couple of bits of aluminium foil with some insulator in between. The piece of insulation that you put between the 2 aluminium strips is called the dielectric. We need to place a couple of bits of copper wire against the aluminium foil to give good electrical contact. The whole thing would work quite well as a capacitor just as it is, but it's made much more convenient by rolling the whole thing up. In order to be able to roll it up, you need to put a second piece of insulation on the back so that the 2 pieces of foil don't touch. Once it's rolled up and the bits of wire are twisted into one, it looks and acts pretty well like any conventional commercial capacitor. Perhaps the most obvious way to increase the capacity is to increase the area of the plates. This spreads the charge out and increases the capacity of the component. The value of the capacitor C is directly proportional to the area A. In other words, if you double the area of the plates, you will also double the capacitance. The charge is pushed onto the capacitor by the potential difference of the supply. However, the attractive force between the positive and negative on the 2 opposite plates plays a major part. That attractive force tends to hold the charge on the plates. If the plates are further apart, the force is smaller. The greater the distance between the 2 plates, then the smaller the value of the capacitance. So if little d is the distance between the 2 plates, then the value of capacitance is inversely proportional to d, i.e. proportional to 1/d. The space between the 2 plates is taken up by a dielectric. A dielectric is primarily an insulator so that a current can't flow between the positive and negative plates. Air is a reasonable dielectric and often used. A vacuum is also good, but rather impractical. The vast majority of dielectrics are solids, because they have the ability to keep the two plates apart. And thirdly, the dielectric should enhance the value of the electric field. In that way, the force between the charges is larger and they are held more firmly on the plates, hence increasing the value of the capacitance. The ability of a dielectric to support an electric field is called the permittivity, and the symbol epsilon is used. However, it is very often expressed as the relative permittivity to free space, where epsilon naught is the permittivity of free space and K is the relative permittivity of the given dielectric. The final equation relating the capacitance to the permittivity area and the distance between the two plates is therefore shown on your screen. It is an equation that you are likely to have to know.